Alrighty, so we're gonna draw this plate using parametric modelings. And what you'll have to do if you don't have Inventor is you're gonna have to fill in all this information here. But I do have Inventor, so I'm gonna run through it in Inventor. And I almost always would tell you that when you are doing this, you should be doing all your parametrics ahead of time and filling it out. But I am just going to go through and run it in Inventor. So I've actually brought this to the other side. I may bring it back to reference it. And if I actually go down, it actually walks you through what it wants you to do. So it's like, okay, first sketch the rectangle and do your dimensions for D0 and D1. Very important to get those right. And then extrude it, and then we put the slot in. And then we put the circle in. It goes through and it shows you individually where you should be doing every part. So I will be following that procedure through here in case you don't see it. So the first thing it would want in Inventor is just for us to do this on the top plane, and it always rotates, so I'm just going to change that, and I'm going to draw my rectangle as such, kind of like that. Dimension is not important because we are going to put that in, and I actually have to go and start looking at the dimension. So it says that D0 should be this face right here. And D0 is very simple because D0 is going to have an actual value. So I'm going to say 3. So D0 is 3. No formula, no nothing. It's just going to be 3. No parametric equation. Now, the second one, it gives you the answer for D1. And D1 is D0 times 5 divided by 3. It gave us this. So it gave us what D1 is going to be. So D1 is D0 times 5 over 3, which is going to give you the function 5 here, which is very good. Okay, so that one was pretty easy. And then the next step would be to extrude the plate, which I am doing. I'm going to hit extrude now. And it says the extrusion is going to be 20 times smaller than the overall width. And the width is D1. So I'm going to say D1 divided by 20, because it's 20 times smaller than D1. Okay. And the taper angle is going to be 0, so that would be right here. This is the taper angle. It is going to be 0, so I can just leave that as it is. Okay, so there we go. I have this. I want to be looking at it from this side, because this is how you would be looking at it. And what are we going to do next? So next we've got to create a sketch on top, and we have to draw a slot. Now there's a couple ways to draw a slot, but I am just going to use the slot tool with 2 centers, and I'm going to try to drop this as nicely as I can in here. Okay, so I have a slot now. Okay, and the slot has 1, 2, 3, 4 dimensions. So the first of those 4 dimensions is D4, which is here to here. So D4 being there to there, and D4 is half of the overall depth. So the depth, if we look at it, the overall depth of the plate was D0. So we're going to say D0, and half of D0 would be dividing it by 2. So that is what we get for that. For D4. Now where is D5? Now D5 is a location dimension. So D5 is from the edge over to the second center. And this is one of the first ones we actually have to do ourselves. So it is 4/5 of the overall plate width. Okay, so there's a couple ways we could do that. So let me see, which one was the plate width? Plate width was D1. So it is 4/5 of D1. So we could do this a couple ways. We could do D1 times, 4 divided by 5. This would be acceptable. So that is 4/5 of D1, just like the other one was a 5 to 3 ratio. This is 4/5. of D1 because it is 4/5 of the overall weight. So we're going to do this, and that'll go in there as a 4. D6 is another location dimension, so we're locating that same hole from this top edge. And D6 is the 1/3 of the overall plate depth. So the plate depth was again D0, and then it is 1/3 of that. So it should be 1 inch, and it is. So there we go. And then the slot diameter is the same as the plate thickness. So if we're going for the slot diameter, we have to click the diameter, and that would be the same as the slot thickness, and it gives us this answer because the plate thickness is D2. So we just have to put D2 in here. Alrighty. All right, and the next we are going to extrude this plate. All right, so we're going to extrude, and we are going to cut it. And it says the extrusion length is the same as the thickness. We already said the thickness was D2. Okay. And the taper angle, which we go into here, is the same as D3. And we click OK. And we have our slot cut out. Very good. So next we're going to make a sketch for our hole. So we're going to do a sketch on the top, and we're going to drop our hole in here somewhere. And I've got to just scroll up quickly. So we should be on D10 now. So this is a good way to check. So from here to here, when we click down, this is in fact D10, so that's very good. We're still on the right track. And it is 1/4 of the overall plate width. So the overall plate width is D1. And then there's a couple ways to do this, but I'm just going to do 1/4 as a quarter, so I'm going to do times 0.25. So that was that one, and then D11 is another location dimension. So I'm going to do this one right here. And what's it asking for D11? D11 is 2/3 the overall plate depth, so the plate depth was D0 times 2 divided by 3. That's 2/3. Okay, so I'm going to click check. There we go. And the hole diameter, so I got to grab the hole here. The hole diameter is twice the slot radius, and it gives us this. This is 2 times D7. So 2 times D7 would give you the hole diameter. And then we're just going to extrude this. So I'm going to hit finish sketch. I'm going to go to extrude. I'm going to click the hole. I'm going to do a cut. It is D2 again. And this would be D3 or D9, really your choice. It's all the same. So I'm just going to say D3. And there we go. So now that you have it drawn, if you're an inventor, what you would do is you'd go to the parametric chart and look here, and these should be all of your model values or nominal values to match, which you could then post to me. Okay, so that's what we're looking for from you if you're doing an inventor. If you are not doing it in Inventor, if you are doing it on, hold on, I got to pull up Google Sheets here. If you're doing it on a Google Sheet, you would then start going in and filling these values out. So this would be I'm going to make this actually a value right here. So for you guys, you make that 3 because that's D0. So you would say equals this. which is D0. And then, actually, no, I'm going to leave it the way it was. Equals, and then you go to D0, whatever D0's value is, and then times 5 divided by 3, and we hit enter, and we should get our 5 in there. Okay. So, and if we went back to my model here, you would see that is what we get here. So this chart should match. Okay. Do you guys have any questions? Feel free to come to office hours and ask them. Okay, so good luck.